2.2 level 1 is simplifying square roots and then cube roots of numbers. So the square roots are very simple should be simple for you guys. They are something that we've done the last couple years. The cube roots might be something new, but very similar to the square root. So I'm just going to go through 3 examples of square roots and 2 examples of cube roots, and then you are free to work on your practice. So just as a kind of review, when you do the square root of a number, whenever you do that, there's like an imaginary 2 out here on top of the square root that says, that tells you it's a square root. So that's why we look for pairs of numbers. So when I'm breaking down 60, I can break it down in a bunch of different ways. I can start with 2 and 30. You could start with 5 and 12. You can start with 15 and 4. There's a number of different ways that you can start this. Doesn't make one way more right than the next. Okay, but as long as you break it down, and then my next thing that I tell you is stop when you have a pair. So that's going to come in number 2. So let's see, I got a pair of 2s here. So I'm going to circle them. So because there's 2 2s, that number, not both of those numbers, just that number 2 comes outside of the square root. And then I am left with the square root, and since the 3 and the 5 don't have pairs, or there's not another one of those numbers, they get multiplied back together and put underneath the square root. Okay, so that would be your answer, 2 square root 15. And don't worry about this little 2 that's out there. You can absolutely put it back on the square, just to remind yourself that it is a square root. That comes more important as we get to the higher numbers that are outside the square roots, so like 3, 4, 5s. Okay, so number 2, here's what I was talking about. So 225, if I break that down, I notice that that is 15 times 15. So here I have 15 and 15. Now here's what I'm talking about. I have 2 of the same numbers. Now I could keep breaking 15 down into 3 and to 5, okay, 3 and 5, and I would have a pair of 3s and a pair of 5s. But I don't have to do that, because in the very beginning, I broke things down into 15 and 15. So I already have a pair of numbers that I can circle. I don't need to break this down any more than I have to. So here's my pair of 15s. The number 15 comes out, and it gets multiplied to anything that's out in front. And now since what's left in the square root, there's nothing that I haven't circled yet, so the square root doesn't exist anymore. So the answer for this one is just negative 45. Okay? So don't break things down. Stop when you have a pair of numbers. You don't have to keep on going. Okay, now number 3 is special. You might see the number 36 and say, oh, that's 6 and 6. Here's a pair and my answer is 6. Okay, but notice that there's a negative 36 and it's negative inside. So let's talk about what the square root means. Having a square root means I'm going to multiply the same number times itself to get that number. So like if we have the example of 36, and you don't have to write this down, just listen to it. So if I have the number 36, I could have the answer be 6, okay, or it could be negative 6 times negative 6. Both of those equal 36. That's what this is saying. That's what a square root is. But if I have the problem of negative 36, I'm trying to find a number that multiplies by itself to equal negative 36. Well, the only way for me to get a negative number when I multiply is when I'm multiplying two different signs. So a positive times a negative and a negative times a positive will all equal negative numbers. But I can't have the same number be both positive and negative. That doesn't make it a square root. So when you have a negative number underneath a square root, there is no solution to this. There's nothing that can be broken down. So you say no solution. The answer is not 0. The answer is can't be done, Mulaney. The answer is no solution. Okay? It's not none. It's no solution. All right, number 4. I've got now the cube root of 24. So like before, I said it was a square root and we put a 2, and that's why we look for pairs of 2s. When it's a 3, you're looking for pairs of 3. I guess pairs doesn't make sense. It would be groups of 3. So when I have 24, I'm going to break that down into, let's say, I don't know, let's go 3 and 8. And then 8 breaks down into 4 and 2. And 4 will be broken down into 2 and 2. Okay, so I'm going to circle this group of 2's. And notice I'm circling 3 of them because it's a cube root. So the 2 comes out. And now I have left the cube root of 3 because the 3 was left over. So for the cube root, it's very important to add in that 3 on the outside of the root symbol. So you want to make sure that you have that. Okay, one last one. Okay, now negative 54. You might see negative and it's a square root, so it's a no solution. You told me that already. However, we're talking about a cube root now. So remember, it's the same number times itself and times itself again, which makes something a cube root or able to be cube rooted. So if I'm trying to multiply 3 numbers to get a negative number, remember a negative times a negative times a negative will equal actually a negative number, because a negative times a negative is a positive, and then a positive times another negative is going to equal a negative again. So a cube root of negative numbers are always going to be possible. You're going to be able to do them. Okay? You're going to break them down the same way that you did with the square roots. So 54, I'm going to say 9 and 6, 3 and 3, 3 and 2. Okay, so I've got a pair of 3's or a group of 3's. They're going to come out. Now if this inside number, this negative 54, starts to be negative, your number that you pull out of the cube root is also going to be negative. So if the inside number is negative, the outside number, that whatever group of 3 that you pull out, is going to be negative as well. And then you're left with the cube root of 2, because that's the 2 that's left over. Okay, so those are level 1, just a review of simplifying roots.